Welcome back, Smart Contracts Maxis, in the part 2 of our ERC-721 NFT smart contracts. In the previous part, we built a smart contract, we compiled. Let's compile again for build and compiling no file change, compile and skip, which means compilation is successful. And in this part, we are going to test. We will write some of the best test cases for this smart contract, and we will learn how testing works in Foundry. And I will show you some of the best practices to test your smart contract. And by the end of this video tutorial, we are going to deploy our smart contract on Rootstock testnet. So I will show you how you Rootstock is different from other EVM chains. So let's get started. I will also show you some of the best deployment practices. So let's get started and start writing testing our for our smart contract. So for that, let's create a new file, my nft dot t dot sol, and inside that let's start writing test. So before writing test, let me show you what we have done in the previous part of this video guide. We initialized the Foundry project, and after that we installed OpenZeppelin external libraries, and we are importing here in our contract. Our contract is ERC721 URI storage and ownable. Here we declared some state variables, then event, constructor, we have mint function here, logic, we also have mint to address, we have get total supply, set max mint for address, and the withdraw. So let's start writing test. I will show you some of the best tests. I will introduce you here some of the Foundry cheat codes. So let's start, copy it from here, SPDX license identifier, and the same version we are going to use here. And now let's import test from Forge Android library, Forge std slash test.sol, and that's it. We also need to import our contract, my NFT from dash sol. And now let's start writing. My NFT test is test. And now let's declare some state variables here before setting the our main function, which is setup function. So let's copy the my NFT, and my NFT, let's make it public, and let's say its name is NFT. Now address of the address public owner, let's say address public user one. And now address public user 2 and address public user 3, and that's it. Thanks to Copilot. Now let's go ahead and declare two more variables here, which is the constant variables, which we will need to test our smart contract. Let's declare this one as well, unity public constant. Now let's say mint price, and let's initialize it 0.01 ether. Thanks to Copilot. Let's declare another constant variable, constant, and the max supply should be, let's say, 1000. And now let's set up our main function, which is the setup function setup, and let's make it public. Now let's initialize our state variables we declared here. So owner, not here actually, yeah, inside the owner is equal to, let's say, we are using here Foundry cheat code, make ADDR, and inside that we have to pass the owner, right? And now let's initialize user 1, user 2, and user 3. And now we don't need this variable. Let's say, let's start pranking. M dot start prank. This is the Foundry cheat code. If you don't know Foundry cheat codes, so you can go here, book.getfoundry.sh, get started, and you can find pm dot start, pm dot start prank, and how it works. So you can see here, pm dot start prank. So this is the examples you can learn from here, Foundry documentation. So I know almost all the cheat codes of Foundry and how it works. Even you can go to rootstock.io and learn more about Rootstock and the Foundry documentation. So you can go inside the docs, and you can search Foundry. They have also Foundry cheat codes, Foundry documentation, how you can use Foundry for Rootstock development. So you can check out there as well. So let's go back and and start testing our smart contract. So for that, let's vm.start and inside that we have to pass this owner, which takes the message.sender. Now let's say let's deploy our contract nft.new nft my nft, and we are stopping the frank. Now let's test our constructor first. So let's go back, and where is our constructor ERC721? Is the name is my nft and the symbol is my nft and my enable is message.sender. So let's test our constructor first, and I will show you how you can. I will introduce you some of the best Foundry cheat codes. We will write some of the best test here, and after that I will show you how you can write deploy script and deploy it on actual Rootstock testnet. So let's test constructor here. So for that, let's function test constructor, function test constructor, and now let's make it public. It's functions visibility. Always remember, when you are writing test in Foundry in Solidity, you have to make your function name starts with test, and your function visibility always should be in public. So let's write functions body. Here we have to. Here I am introducing another cheat code, which is assert equal. You have to give the value of the right side, left side and the right side. So let's get started and let me show you. So first we are going to use this assert equal, and the left hand side we have to pass nft, sorry, not mint, actually we are testing constructor. So let's test our name first. So nft name, and let's name it on the right hand side my nft, and let's test now symbol. So on the left hand side, nft dot symbol, and on the right hand side we have to pass, let's say, mnft. I forgot to add this one, mnft, and let's test now the owner. So assert equal, let's copy me because we need to add more. nft dot, let's say, owner. We are passing the owner, and on the right hand side we have to pass owner here. And now let's test the total supply. Let's say assert equal and if get total supply. By the way, where these functions are coming from, I already showed you in the previous videos, and in this video also we installed OpenZeppelin libraries, and in the OpenZeppelin library, in our contracts, we are importing these contracts from OpenZeppelin, and that is inherited. So if you have understanding of inheritance in Solidity, so you will get it. And all the ERC 721 functionalities access we have in our contract, and this is what we are calling here for the testing purposes. So get total supply, let's say 0, and now let's assert equal max supply. So equal, I forgot, add nft max supply, and on the right hand side we have to pass the max supply, same. And now let's add assert equal mint price, and on the right hand side mint price. Now let's say another cheat code, nft dot max mints per address, and we have set here not but 5, if you remember. Let's format this, and with that, this is the test constructor functions we have written. Now let's add another. Let me show you constructor. After that, let's test this mint function here, and I will write 2 4 test, and I will assign you some task to write more text. But in the description of this video, I will be giving you GitHub repo to to follow, and in that repo I will add more tests, like 15 tests. This is just this is just show you to how you can test your contracts in Foundry. So let's go ahead and let's test our main mint function. For that, let's create a function test mint, which is taking no parameter. Let's make it public, and let's start writing. So first here declare a state variable. Let's name it string memory token URI, and let's say, for example, IPFS colon slash slash UMEST, let's say 123. or whatever. Now let's use here the deal vm.deal, the new Foundry cheat code vm. And inside that we have to pass two parameters. One is the account. Let's say for account user1, and let's say mint price, new balance, let's say mint price. And now let's go ahead and start franking. So let's vm dot start frank, and inside that message dot sender user1, we have to pass the user1. Now let's go ahead, and here I am again introducing you a new Foundry cheat code, that is expect emit, and inside that we have to pass the boolean values. So let's make it true, and another true, and let's make it this time false, and now again true. That's it. Now let's format this, and now let's emit an event here. Since we are using expect emit here, let's emit here NFT minted, and inside that let's pass user1 1 and token URI. And we didn't declare the event here, so let's go outside this mint function and let's declare event here, event NFT minted. And inside that we have to pass address of the two UNT56, the token IDs, let's say token 2256, token ID, and token URI string, token URI. Thanks to Copilot. Now let's go ahead, and we have emitted the event here. Now what we have to do is let's try minting. So NFT dot, and inside that we have to pass and the value, and we are calling mint price here. So let's copy mint price from here, and let's say mint price, and now here we have to pass the token URI. Let me token URI, thanks to Copilot. And now let's go ahead and stop the prank. So vm.stop prank. Now let's add more assert equal here. Let's copy from me, and inside that on the left hand side nft dot owner of, let's say 1, and this side user1. Let's add another assert equal here, and there nft dot token URI, and 1 token URI, thanks to Copilot. Let's add another assert equal, and there this time now we have to pass get total supply, which is the 1. So nft dot get total supply, and this time we have to right side the 1. And now let's go ahead and let's add another assert equal for the minted counter. If you remember, we declared the mapping here in our contract minted count. So let's test this one assert equal nft dot, and inside that minted count let's say user1, and on the right hand side the 1. And that's the our test mint. We will test it, don't worry. And what warning we have here, function statement where I can restrict it to you. So this is just minor warning, so don't worry about this. Let's go ahead and start write one more test. So I will show you how you can test, but in the video description I will give you code, entire source code of this tutorial. By following this you can write more test, more than 14 15, whatever the test you have to write. You can literally test every single line, but if I write more test here, and this video will be so long, so I am just showing you how you can write test. So let's test our more functions here. So we can test more here functions, but let's keep going. Let's first see our test is passing or not. So for running this command, let's say for test, and to test fast, the test dash vvv, and this is the assignment you have. By following this you can see we have our one test failed. I deliberately did this, and what is the problem you have to identify and solve this problem. And I am also giving you source code of this tutorial, so you can go back there and you can solve this problem. So inside the constructor you can see here in traces what is the exactly problem, you can clearly see and you can solve this problem as well. So that's it. Let's write our deploy script and let's deploy it on testnet, rootstock testnet. So for that, let's go inside here, inside the script folder, and let's create a new file, deploy.ps. Copy this from here and paste it here. Deploy script is script. And where this script coming from? It is coming from for standard library, script from for standard library. And we also need to import the contract we are deploying. So what is our contract name? My NFT dash dash those NFT. And let's declare here our main function, which is the function run. Let's make it external. Now let's declare here the address of the deployer, and let's say message dot sender. And now let's start broadcasting our transaction dot or broadcast, and inside that let's deploy my NFT. It's, let's say, NFT is equal to new my NFT, and before stopping the broadcast we need to print or the print in our console to all the information. So I will show you how you can do this. This is just a different deploy script than previous videos. We just deployed and we didn't print it. So I will show you how you can print all the information related to your smart contracts in the terminal. So let's clear this and pull it down. Yeah, now here first thing we have to do is to import console from for standard library, and now let's print one by one. So first console dot and let's say my NFT deployed at, and there we have to pass this NFT. That's it. Sorry, we have to pass here address, and inside that we have to pass NFT, and that's it. Now let's add one more console here, console log, and now we have to pass deployer, the deployer address, and let's say deployer address is the deployer, which is the message dot sender. Now let's print contracts owner name, symbol, and everything. Let's console dot log, and now let's add here contract owner and NFT dot owner. Thanks to Copilot. Let's add another console here, console dot, let's say, contract name or the token name. Let's pass the token name, and if same with console log, inside that we have to pass the token symbol, which is the NFT dot symbol. Thanks to Copilot. Let's format this. This is going to be messy code. So let's add another console here, console dot token. Let's say we have token symbol and name here. Now we need to pass the maximum supply. Let's say max supply, and let's say max supply is NFT dot max supply. We declared already. Let's add another console here, console dot log. Let's say mint price here. Now let's pass here the NFT dot mint price. Let's add our last console here. So you will get printed all the information related to your contract on your terminal. So let's say max mint, and let's say NFT, let's call maxmint for address function here, and thanks to Copilot, let's format. By the way, I showed you how you can format entire your Solidity code by running this command for fmt, and you will get formatted all the your Solidity files, no matter how files big. This is and we have to pass vm dot stop broadcasting. So we tested our smart contract and we have one failed test here. This is kind of assignment for you. So in the source code I will give you everything, but try it by yourself, try solving. This is not very much challenging. So when you are challenging yourself, you actually learn things. So our deployment script is ready, our test cases are ready, and we are ready to deploy. But before deployment, we have to make some configuration in our foundry.toml file. So first thing we have to do is here the sol version or Solidity compiler version, which we are going to use. Let's say 8.20 0.8.20. This is the exact version we are going to use, and we have to pass here EVM version. We have to set here EVM version London, because Rootstock is using legacy transaction mechanism, and they are also following 1559. So if you don't know, you can go back and learn about London fork, and even on Rootstock documentation you can find all the documentation related to transactions. So for that we need to pass here one more as an RPC endpoints, and here we have to pass Rootstock. We have to declare Rootstock Testnet, and let's say I'm going to use this TTS. This is the public RPC URL, so you can use RPC. Sorry, public dot testnet dot sk dot co. You can also use this one if you don't know. You can go to Rootstock documentation, and here you can find so you will find all the documentation if you want to use RPC URL or the API keys. But this one I got from their documentation, and you will find a lot of documentation to get started and how to do XYZ here on documentation. I will show you testnet RPC URL. I'm searching here, and you can see here the JSON RPC URLs to connect with Rootstock. So this one is I am using. You can also use the RPC URL from Alchemy. Alchemy is also supporting Rootstock, and you can use there as well. So we are ready to deploy our smart contract. We set up the things. Make sure you have imported your wallet, because we are not using .env file here. So I already encrypted my wallet inside my Foundry. You can do by running this command cast import wallet. I guess this is the you can run the cast, and you will get all the cast commands here. So by running this command, you can import your wallet. Let's say wallet, and you will find all the commands related to wallet. So you can use cast new and create a new random key here, vanity, address, verify, import, list. So you can see here, if I run cast list, and I have Pandit named wallet. I encrypted my private key in my Foundry, and I named my wallet is Pandit. So I'm using the same account to deploy. So let's deploy our smart contracts. We are good to go. To deploy, run this command for script slash deploy.s.sol, and inside that we have this deploy script. Let's paste here deploy script. Now we have to pass dash dash rpc dash URL, and we have what variables we have: rootstock testnet, and let's say dash dash account I already showed you here. I'm going to use my funded dash dash sender. The wallet address we have to pass here. Let's me open my wallet, copy this is the address. This address private key and I encrypted. So sender is this address, and now we have to pass broadcast here, and also dash dash legacy. And before going ahead, make sure you have faucets in your wallet. You can go to faucets, rootstock faucets.rootstock. Copy your address from here. I already showed you this in previous part, but I am going to get more tokens. Check it here. I'm not robot. Let's verify here. Copy here address. Let's check it. I'm not robot, and get test RBTC, and wait for some moments to get some RBTC. So I have here, you can see I am on Rootstock test network, and I have 0.0198 TRBTC, which are enough to deploy our smart contract. So run this command for script slash deploy.s.sol, and inside that deploy script dash dash rpc URL rootstock testnet account Pandit, and sender this address of mine, and broadcast dash dash legacy. Let's hit return, and let's wait. Compiler is successful, and let's wait for some time. Just bear with me, and our smart contract will be deployed. So you can see logs. So let's go here back, and as we printed in our console, and it is asking me to enter the key store password. So I'm entering my password, and let's wait for deployment. So you can see our deployment is in pending. NFT deployed at the address of the NFT. Our address the same B9. So if you see the sender we have declared the sender we have sent here 0x339 and the last B9. So you can see the deployer address 0339 and FB9. The contract owner is the same, uh, and the token name is my NFT. If you remember in our contract SRC, what is our token name? We initialize here my NFT, right? And the token symbol is MNFT. Maximum supplied. Actually, we did some spelling mistake here. Instead supply we did supplet, so it's okay. And the min price is this much. This is the price is in GUI, and maximum p means for address. We have implemented the logic of the 5, and you can see our transaction is successful, and we successfully deployed our smart contract on Rootstock test network. So let's see if we indeed deployed or not. So let's copy this contract address from here and go to Rootstock Testnet Explorer, and this is explorer.testnet, and copy this contract address, paste it here, and let's see. So you can see the address of our contract name is my NFT, the symbol is the same, the creator, and the deployed at timestamp 1 minute ago on July 4th UTC, and that's it. With that, I am wrapping this video, and I will see you in next video. If you here with me, thanks for watching, and I am going to give entire source code of this smart contract, all the test cases in the video description. So if you stuck anywhere, don't hesitate to ask help in Rootstock Discord and community channel. Thanks all. I will see you in next one.